I want to take the derivative of more than 3 functions. So let's just look at 4 for now. Let's say f times g times h times j. If I want to take the derivative of this, I'm going to need 4 terms because there's 4 functions. So the easiest way to do this is to write out 4 terms with f, g, and j. And then we're going to apply the derivative for each function at a time. So we're going to have, first we're going to take the derivative of f, then g, then h, then j. And then we're just going to add them all up. What happens if we have 5 functions? So let's say we have f, g, h, j, and k. Because we have 5 functions, we're going to have 5 terms. Each term is going to have each of those functions. And then we're going to take turns taking the derivative. So first we're going to do f, then g, then h, then j, then k. The pattern continues like this for more than 5 functions. So it's a very nice way of simplifying the product rule for any function being multiplied. As many functions as you want it to be multiplied. So let's look at a couple examples. Let's say I'm given y equals x squared times e to the x times natural log of x times sine of x. I want to apply the product rule. So I'm going to be taking the derivative of each one of these functions at a time. So the first term will be x squared. What's the derivative of x squared? Well, that's just 2x. And we're going to leave everything else the same. Okay. Next, let's take the derivative of e to the x. The derivative of e to the x is e to the x. And then keep everything else the same. So we did x squared, we did e to the x. Next in line is the natural log of x. What's the derivative of natural log of x? 1 over x. And then keep everything else the same. Last one is sine. What's the derivative of sine? Well, that's cosine. Leave everything else the same. Now the only thing we can simplify here is the 1 over x and the x squared. So the 2 is going to cancel and we're only going to be left with x. Now let's see what do all of these terms have in common. We have an x for all of them. We can write that down. We have an e to the x. And that's it. So let's see what we have left. For the first term, we have 2 times natural log of x times sine of x. The second one, we borrowed an x, but we have a 2 here in the exponent. So that means we need one other x. Then it's natural log of x sine of x. And for the third term, that kind of worked out nicely. We only have, let's see, sine of x. And the last term, we have cosine x, x, and natural log of x. And we'll just leave it at that. So that's the derivative. Okay, next one we'll be looking at 5 different functions being multiplied. So we have 1/4 times square root x plus 1 times e to the x squared times tangent of x times natural log 5x times x to the negative third. Okay, so now we're going to be taking the derivative of each one of these at a time. So let's identify each one. So we have square root x plus 1, e to the x squared, tangent x, natural log 5x, and x to the negative third. The constant, we could just leave it out in front. So honestly, yeah, we could just factor it out. So we can just have it hanging out outside here. And then we can just worry about, the 5 functions that we're multiplying. So we're going to go in order. We're going to be first finding the derivative of square root of x plus 1. So really the square root of x plus 1 can be rewritten as x plus 1 to the 1/2 power. We're going to apply the product rule here. We're going to bring down the exponent, keep everything the same inside, and then subtract 1 in the exponent. The derivative of the inside is just 1, so I'm not going to bother putting it there. Okay, so we have the derivative of the first one, and then we're going to leave everything else the same. Okay, next we're going to go to e to the x squared. What is a derivative of e to the x squared? Well, e to the x squared is going to be itself multiplied by the derivative of the exponent, which is just 2x by the chain rule. Okay, and then we're going to keep everything else the same. We have square root of x plus 1, tangent of x, natural log 5x, and x to the negative third. Okay, next one we're going to be looking at tangent of x. What is the derivative of tangent of x? That's going to be secant squared. Okay, and then leave everything else the same. So we have square root x plus 1, tangent, e to the x squared, natural log 5x, and x to the negative third. Moving on to natural log of 5x, what's the derivative of that? Well, it's going to be 1 over 5x times the derivative of 5x, which is just 5. So that's just a chain rule. And then we keep everything else the same. We have square root x plus 1 times e to the x squared times tangent of x and times x to the negative third. And finally, we're going to be taking the derivative of x to the negative third power. So we're going to bring it down and subtract 1 in the exponent. And then multiply by the rest. So square root of x plus 1, e to the x squared, tangent of x, and natural log of 5x. So it's really this entire thing. And then we have to multiply or distribute the 1/4. But really, I'm not going to bother doing that. The next step is to identify what we want to factor out. And this is the hard part. A good starting point is to look at e to the x squared, because you know the derivative involves e to the x squared. So that's a very good candidate. So I'm going to just put everything out here just to help me organize. So I'm going to factor out e to the x squared. Let's see. I'm going to skip x plus 1 to the positive 1/2 or negative 1/2 for now. That's a little tricky. Tangent of x, they don't all have tangent of x. Skip that. They don't all have natural log of 5x. Skip that. But they all have x to a power. So before I talk about that, I'm going to simplify this 5 here. And then here I have 1 over x times x to the negative third. So that's going to be replaced with x to the negative fourth. Okay, because x and negative, 1 over x times x and negative third is really x and negative first times x and negative third, which is x and negative fourth. And okay, so now let's revisit x plus 1 to the negative 1/2 or positive 1/2. All of these, the square roots are positive 1/2, but this is a negative 1/2. So in this case, you always choose a 1 with a smaller exponent. So that's going to be negative 1/2. And then the last one, we have to look at x and negative third, x and negative fourth here, and the x and negative fourth. So we choose a smaller of the exponents, which was it'll just be x and negative fourth. Okay, and then I have the 1/4 out here, so keep that there. And now let's factor. So this is for the annoying part. Okay, so the first one we have 1/2, then times tangent of x, natural log 5x. And I'm just gonna write it vertically, just to make it easier. Actually, this one I kind of goofed up a little. So we have x and negative third. That should be x and negative second. Okay. So, okay, let's keep that in mind. Okay, so we have a 2, and then I pulled out an x and negative fourth, so I'm going to multiply that by x squared to get x to the negative second power. I still have a tangent of x, natural log 5x. Okay, go on to the next term. I have secant squared. And, okay, the last one I forgot. It's square root of x plus 1. So that one we just need x plus 1. Okay, because when we multiply x plus 1 to the negative 1/2 with x plus 1, you're going to add the exponents. So negative 1/2 plus 1 is x plus 1 to the 1/2, which is what we want. And same thing with this one. And next one is natural log of 5x. Okay, and then we have a square root of x plus 1, so we know we're going to have to multiply by x plus 1. And tangent of x. Okay, the last term, we have a negative 3, and then we're going to also multiply by x plus 1, tangent x, ln of 5x. And at this point, yeah, this should be good enough. So we don't need to go any further. So this is the derivative.